In this video, I'm going to be talking about the 3 different cases when the limit does not exist. For this first example, we're looking at the function f of x, and we're going to be looking at the limit as x approaches 1 of the function f of x. We can already see here that we have a special case where x equals 1 because we have this big jump in our function from 1 to 2 all of a sudden. Whenever we're looking at the limit as x approaches 1, we're asking ourselves, what is the behavior of my function, or what is the value of my function approaching as I get really close to 1 from the left and from the right? Well, here, if I trace along my function from the left of 1, and I get really close to 1, I see that the value of my function is approaching 1. And then if I trace along my function from the right of 1, and I get really close to 1, I see the value of my function is approaching 2. Here, because the value of my function is not approaching the same value from the left and from the right of this x value 1, we have that the limit does not exist. And here let's write down for ourselves, that's because the behavior of our function differs from the right and the left. Let's look at this next example where we have the function g of x. Here we're looking at the limit as x approaches 0 of this function. So we're going to look at what is the function approaching from the left and from the right of x equals 0. And if I trace along my graph from the left, I see that I'm going up to positive infinity. And if I also trace along my function from the right, I'm going up to positive infinity. Now for the limit to exist, my function has to be approaching a finite value. Here we see that my function is not approaching a finite value, it's going off to infinity. So here again we say that the limit does not exist. And if my function is going off to infinity, it can go off to positive infinity or it could go down to negative infinity. We call this unbounded behavior. Let's look at our next example. So our next example, we have the function h of x, and we see that something really interesting is going on with my function as I get close to 0. And I am asking, what is the limit as x approaches 0 of this function h of x? So what's happening here is what's called oscillating behavior. Oscillating behavior is when my function is bouncing back and forth really fast between 2 different values. So here my function is actually bouncing back and forth between 1 and -1. And I did my best to show this, but as you get closer and closer to 0, this function is going to be moving faster and faster between 1 and -1. That means that my function is never settling down to one particular value as I get really close to 0. In order for the limit to exist, we need for our function to be approaching one finite value as I approach 0. Since that's not the case when my function is oscillating, we see that here, again, my limit does not exist. And that is because of oscillating behavior. These are the 3 particular cases when the limit does not exist. If you want to see particular examples of functions that have these behaviors, I am going to be creating videos with specific examples. So if you want to find those, you can find those on my channel.